Every time you get a cut, neutrophils spring into action to protect the body from infections. It is well known that neutrophils can ingest and kill tiny bacteria one at a time. However, it is less known that neutrophils can also neutralize fungi that are 100 times larger than neutrophils. A molecule named leukotriene B4 was recently found to help neutrophils coordinate their actions together against fungi. Leukotriene B4 is initially released by the first neutrophil on the fungus. Then it activates the surrounding neutrophils, which start moving towards the fungus. The activated neutrophils also release more leukotriene B4. Recently, researchers at 5 top institutions, using a fluorescent probe that measures neutrophil activation, observed that neutrophil activation around fungi follows the pattern of a wave. Surprisingly, the wave stops at some distance from the target, limiting the number of neutrophils that move towards the fungus. If this activation wave was to continue unopposed, all neutrophils from the body would come to the site of injury and leave the rest of the body unprotected. The stop could not be predicted by what is known about neutrophils. The researchers proposed that a brake mechanism must be involved. A molecule named NADPH oxidase is activated by leukotriene B4, then accumulates slowly inside the activated neutrophils and prompts the return of calcium levels to a resting state. This process limits neutrophil recruitment. To verify this mechanism, the scientists added inhibitors of NADPH oxidase to the neutrophils. As predicted, the wave of activation expands outwards without stopping. Even more interesting, neutrophils from patients with a genetic disease that alters NADPH oxidase accumulate in large numbers, and even at sites where there are no targets. Future studies will expand our understanding of the neutrophil swarming function in health and disease.